Okay, let's talk about AI and machine learning. If you've ever felt like those two terms are kind of used interchangeably, well, you're not wrong, and you're definitely not alone. They are easily the biggest and maybe the most confused buzzwords in all of tech. So let's crack the code and set the record straight once and for all.
So, right to the big question. Are they the same thing? The short answer? No, not at all. But the long answer? Well, that's where things get really interesting, because it shows you how all of this amazing modern technology actually works.
And that's exactly what we're going to do right now. We're going to break down what each of these terms really means, and, this is the important part, show you how they fit together perfectly. All right, first things first, we have to start with the big picture, the original dream, and that is artificial intelligence.
The number one thing to understand about AI is just how huge it is. It's not one single technology. Think of it as this massive, overarching field of computer science. The goal has always been to build machines that can do things that normally require a human brain. Stuff like reasoning, learning new things, and solving tricky problems.
And this dream is way older than most people think. The actual term artificial intelligence was coined all the way back in 1956. It's been a long road since then, with these big waves of hype and excitement, followed by so-called AI winters where funding dried up and progress kind of stalled. But every single one of those phases laid the groundwork for the absolute explosion in AI that we're all living through today.
So what is it that's actually driving today's AI boom? Well, it really comes down to one incredibly powerful idea: machine learning. You can think of it like this. If AI is the car, machine learning is the supercharged engine that finally lets it go from 0 to 60.
And here it is, the most important distinction you need to know. Machine learning is a subset of AI. It's a specific way to achieve AI. Its superpower is giving computers the ability to learn directly from data, without a human programmer having to sit there and write a million if-then rules for every single possible scenario. This idea, it completely changed the game.
If you take away only one single thing from this entire explainer, please let it be this. All machine learning is a form of AI, but not all AI is machine learning. There are other branches of AI out there, like old-school rule-based systems that don't learn from data at all.
A great way to visualize this is to picture those Russian nesting dolls. Artificial intelligence is the biggest doll, the entire field. And machine learning, that's a smaller but super powerful doll that fits right inside. It's a specific approach for achieving AI.
And this really gets to the heart of why ML was such a massive breakthrough. You see, early AI, what some people call good old-fashioned AI, worked from the top down. Experts would try to write a rule for every single thing a program might encounter. It was a transparent box because you could follow its logic, but man was it brittle. It would break the second it saw something new. Machine learning just flipped the whole script. It works from the bottom up. Instead of feeding it rules, you just feed it tons and tons of data, and it figures out the patterns all by itself. It's incredibly powerful, but it can sometimes be a black box, making it tricky to know exactly how it reached a specific decision.
Okay, so if a machine isn't just following a long list of rules, how in the world does it actually learn? Well, it turns out there are three main ways.
First up, you've got supervised learning. This is where you basically give the machine the answer key. You feed it labeled data, like a billion emails already marked as spam or not spam, and it learns to predict what to do with new emails. Then there's unsupervised learning. Here, you just dump a whole mess of unlabeled data on it, and its job is to find hidden structures all on its own, like figuring out which customers buy similar products. And finally, my favorite, reinforcement learning. This is all about trial and error. An AI agent learns by getting rewards for good actions and penalties for bad ones. It's how an AI learns to play a video game or, and this is a big one, drive a car.
Now, this massive explosion in machine learning didn't just happen because of some clever new software. It was only made possible because of a parallel revolution in computer hardware.
This is seriously my favorite analogy for understanding the hardware side of things. Think of your computer's main processor, the CPU. It's like a Formula One race car. It's designed to do one single task at a time, but to do it incredibly fast. A GPU, which originally was for graphics, is totally different. It's like a giant fleet of tractors. Now, any single tractor is way slower than the race car, but together they can plow an entire massive field all at once. That ability to do thousands of things in parallel is exactly what machine learning needs to chew through all that data.
And the difference in scale here is just staggering. A really powerful CPU might have something like 32, maybe 64 cores.
but a modern GPU has thousands of them. That massive parallelism is the secret sauce. It's what allows these chips to process the mountains of data required to train the AI models we use every day.
Okay, so we've got the concepts down. AI is the goal, ML is the method. CPUs are race cars, GPUs are tractor fleets. But why does any of this actually matter in the real world?
It matters because they all have to work together, like a perfectly specialized team. Think about the typical journey of an AI model. First, all the data has to be cleaned up and put in order. That's a one thing at a time kind of job, perfect for a CPU. But then comes the heavy lifting, the actual training. That requires the parallel brute force of a GPU to process everything at once. And finally, when the trained model is out in the world making predictions, either chip might handle it, depending on what's needed.
And you see this beautiful partnership absolutely everywhere. For a self-driving car, the goal is artificial intelligence, a car that can think and drive like a human. But the method it uses to learn how to spot a stop sign is machine learning. When your streaming service recommends a show, the AI goal is a perfect, personalized experience, and the ML method is finding the patterns in what you watch. It's always the goal and the method, AI and ML working hand in hand.
So where's all this headed? Well, maybe the future isn't a fight between the old AI and the new AI. Maybe the real holy grail, the next great challenge, is figuring out how to merge them. Imagine combining the explainable, trustworthy logic of that transparent box with the incredible pattern-finding power of the black box. That could give us systems that are not just powerful and intelligent, but also truly understandable. Now that's something to think about.